So in this video, we're going to see how we can use Desmos to find the equation of a sinusoidal function. So if you remember back to pre-calculus or an algebra class you had somewhere, you talked about lines of best fit. And you had a scatter plot, and you tried to figure out what was a linear function that fit that data the best. Well, we can do the same thing with other functions. You probably saw it done with quadratics or other polynomials. You saw it done with exponentials and logarithmic functions. Now we're going to do it with sine graphs. So here's how we can use Desmos. So I've got my data set here, and I'm going to pull Desmos up. Let me see if I can pull it out. So the first thing we need to do is insert our data. So we're going to go to table. Notice it popped up an X1 and a Y1. My X's are going to be months in this case. So I'm just going to type in 1, 2, 3, all the way to 12. And then my Y's are going to be the average temperature. 25.5, 29.6, 41.4, 52.4, 62.8, 71.9, 75.4, 73.2, 66.6, 54.7, 43, and 30. Oops, 30.9. So there's all my values. So you can see as I type them in, they're showing up here. If they're not showing up for you, then you can adjust your window over here on the right hand side. Let me see if I can get that in there. You can hit graph settings and you can change this. So my x's are going from 1 to 12. I mean, I could change this 0 to 13 if I wanted to. And then my y's, it looks like the smallest one's probably around 25. So I can change this to go 20. And my biggest one, 75. So maybe we go a little above that, 80. And you can see that entire graph there. And you can change it however you wanted to if we wanted to go a little bit bigger. Or you can click the magnifying glass over here, and that will do a zoom fit, which will automatically adjust your graph to see all those data values. Now we've already got all the data values here in, but if I do that, it's going to zoom it out a little bit more so you can see things a little bit better. So how do we do that sine regression? So we're going to go down here. We're going to type the equation of the line. Now I've got to reference these two values, right? So I'm going to type in y1. Okay, notice it made that one a subscript. And then I need to use the approximation sign. That's going to tell it to do a regression. So I'm going to go into my keyboard, go to ABC, and you're going to see that regression thing here. That's what we're going to use. So it's going to be in the form of A sine B x, but remember, we got to reference this x here, so it needs to be x1 plus c, and then we have plus d on the end. Okay, so we're thinking about what that a value, that's your amplitude, would be. We're thinking about what omega would be, what phi would be, and then whether or not we're shifting up or down. And then it's going to tell you what your r squared value is. So this guy's a pretty good fit because that r squared is really close to 1. And you can see how it's going through those points pretty well. It's a little off in a few areas, but we would expect that because it's not going to be exact. And then it tells us what our amplitude is, what our omega is, what our c is, which would be the phi, and then how far we shifted up or down. So we could write that equation out over here. Let me see if I can get everything on the same plane here. So then our graph would be y equals A25, I'll round 2 decimal places, sine of B 0.48x plus C, where C is negative, plus D. So there's our sinusoidal regression graph. And then we could use that if we wanted to answer questions.